In this video we are going to improve our AI, and to do that we are going to use a very popular algorithm called Minimax. The idea here is that the AI is going to look forward in the future, like maybe 2 or 3 moves in the future, and take into consideration the score of the AI and the player. It's going to simulate dropping pieces not only for the AI but also for the opposing player. And in the process is going to try to maximize the score for the computer and also try to minimize as much as possible the score for the opposing player. So let's start by creating a function in our connect4.js file, and I'm going to put it at the beginning, maybe right here, just below the getScore method. So export function Minimax. This is going to take the board, the depth, which is going to be how many moves it's going to look forward in the future, and then a Boolean parameter to determine if this is the maximizing player. So let's call it maximizing player. Now this is going to be a recursive function. So the first thing we are going to know, or the first thing that we are going to try to determine, if this is the last iteration, the terminal point of the execution. So let's say let isTerminal equal to, and the termination conditions will be either player 1 wins, player 2 wins, or there are no more valid places to drop a piece in. So the first one is winning move board red, so that'll be if the red player wins, or is winning move board yellow, or we don't have any more valid columns. To do that we can just say get valid columns board, and since this is going to return an array, we can just say length equals 0. So if length equals 0, that means actually if length equals 0, that means that the board doesn't have any more valid columns. So if any of these 3 conditions are true, then isTerminal is true. So here we can say if isTerminal, or we simply reach the maximum depth, so depth equals 0, then we have to return something. Now we have to choose what will be the end score in this terminal condition, but we have several options. So if the terminal condition was reached because we won the game, the computer won the game, then we want to return a very high score, meaning that that will be a very attractive position to drop a piece. If by the contrary the red player won, that means that we have to return a very low score so that the computer will not favor that column. And if neither of those is true, then we simply return maybe 0 as a score. So first of all we say if isTerminal, meaning that one of those conditions is true, then we check if isWinning move board red, that means that player 1 was the winner, so we return a low score. And we can probably optimize this a little bit by saving this call into a variable so that we don't have to call it again here, but that's up to you. I'm just going to leave it like this. So here we return minus, let's say something really low, 1000 maybe, or 10,000 even. Now if that wasn't the case, then we do another if isWinning move, but in this case with board and yellow, meaning that the AI was the winner. So let's return a very high score of 10,000. If neither of those was the case, then we return 0. Now we also have to consider that maybe none of this was true. So isTerminal will be false. In that case, we are going to return whatever score the board has. So return board score and then pass in the board. Okay, now that we have the terminal condition out of the way, we have to move on to the scenario where we are not in a terminal condition. So we have to analyze all of the columns in the board and make a decision based on the score. So first thing to do is to get all of the valid columns. So valid columns equal to get valid columns, and we pass the board. And here we are going to make a decision. If maximizing player is true, then we do something. We are going to look for a high score or favor a higher score. Otherwise, we are not the maximizing player, so we are going to try to minimize the score as much as possible. So we are going to initialize a score variable, and we are going to give it an initial value of something really small. In fact, the smallest value possible. So that way we will always get something at the end. No matter how low the score is, we will always get something higher than the initial value. To do that, we can simply use -infinity. Now what we are going to do is iterate over the valid columns array with for let I equal 0, I less than valid columns dot length I++. Now let's get that column out into its own variable with new column equals valid columns add index I. Next, if we want to drop a piece in this column, we need to get the next open row. So let row equals get open row with the board and the column, which is new column in this case. Now we need a copy of the board so that we can drop a piece in it. So let board copy equals copy board, and we pass the current board. Now we can drop a piece in that board copy, so drop piece in the board copy, add row and new column, and the color will be yellow, because if we are in the maximizing player, meaning that this is true, that means that the turn is for the AI, which always plays yellow. Now this is the place where the recursion takes place, because we are going to call Minimax again, and we are going to get a score from it. So let's say let new score equals a recursive call to Minimax, and to it we are going to pass the board copy that we used to drop a piece in it, the depth -1, and in the maximizing player variable we're going to pass false, meaning that this will be the turn of the minimizing player. Now when we get a score back, if the new score is greater than the current score, then we assign the value of new score to the current score, meaning that we have a higher score now. So score equals new score, because what we are trying to do here, remember, is maximize the score as much as possible. And once we have evaluated all of the valid columns, all we have to do now is return the score. Now, for the minimizing player part, it's going to be very similar. First, we initialize the score, but this time we are going to go with score equals infinity. We want the highest value possible. Now what we have to do is iterate over the valid columns again. So for let I equal 0, I lower than valid columns dot length I plus plus. And this logic here will be very similar to this one up here for the maximizing player. So I'm going to copy these 3 lines and paste them over here. So we get a new column out into a variable, we get the next open row, and we copy the board. Now we have to drop a piece in the board, or rather in the board copy, add row, new column, but this time it will be a red piece. Now we need the score after dropping the piece, so let new score equal to Minimax, and to this recursive call we are going to pass the board copy again, depth -1, and maximizing player equals true. Now we have to analyze the new score. So if new score is lower than score, remember we are looking for the worst score possible when we are not the maximizing player, but instead we are the minimizing player. So we assign the new score to score, so score equals new score, and once we are done iterating over the valid columns, we return the score. And that's it. That's the whole Minimax algorithm. But in order for this algorithm to be useful for us, we not only need to know the score at the end, but also the column that generated that score. So let's add a few modifications to make it useful. So up here, right after the score is initialized, we are going to initialize a column. We will initialize this column to a random value in the range of 0 and the length of the valid columns array. So let column equals math floor math random times valid columns dot length. And very quickly, just to explain what this line is, if you don't know already, math.random will give you a random number between 0 and 1. Here, let me show you in the console actually. So if we do math.random, what you get is always a number between 0 and 1. Now if you multiply that by an integer, in this case is the length of an array, let's say 6, then what you get is a number between 0 and 6. So you keep multiplying that, 5, 4, but you have this decimal component. So that's why we do math floor to that math random times the length of the array, and that gives you a random number that is always in the range of 0 and the number you are multiplying with. Okay, now that that's clear, we have a column initialized to a random index. So down here, when we know that we have a current new score, let's do column equals new column as well. Now when we return, we need to return 2 values, the score and the column. So I'm going to return an object instead. So score is score and then column with the value of column. Let me just clean this up a little. Now if we do this, we have to do the same thing across the board. For example, up in the terminal condition here, we now have to return not only a high score, but also a column. In this case, we are just going to return a value of undefined for the column, like this. Score 10,000 and column undefined. And the same thing we have to do for the other return value here. So I'm just going to copy this, paste it here, and take off the negative. Same with this return over here. This will be a score of 0 and an undefined column. And finally, this return here will give us a score of whatever board score returns and an undefined column. Clean this up. Now we not only have to be consistent in the way we return values, but also in the way we expect the values in return. For example, here we are expecting, or we were expecting just a score, but now it's an object. So what I'm going to do is create another variable called result equal to this Minimax call, and then new score will be result dot score, and the rest can stay the same. Now let's do the same here on the minimizing player. So let result equal this call to Minimax, and then new score equals result dot score. And this return value here has to change, so I'm going to copy the one above here, paste it here, and now we have to assign the column as well. I think we did it right after this assignment, so let column, and actually I'm going to go and copy it from above, just this line here, paste it down here, and over here then we say column equals new column. Okay, I think we are done with the Minimax function. Let's save that. Now, if I'm not mistaken, all we have to do now is go back to the component in the AI turn method down here. Instead of selecting the column using the select best column method, we're going to comment that out and say let column equal to this, or actually connect for Minimax, pass this board, and for depth let's try a value of 2 for now. And actually this won't be the column, this will be result because we are expecting an object in return, and the last parameter will be true because we are going to start with the maximizing player. Now we can say let column equal to result dot column. And I think that's all we had to do. Let's save this and make sure we don't have any errors in the terminal. And looks like it's complaining about the constants. Did we not export those? Let me see. Back to Connect 4. And nope, we didn't export them, but we are using them in the component up here. So we just need to add export to all three. Okay, save that. Check for errors and they're gone. Perfect. Now let's go to the browser and try this out. And I think that'll do it for this video. In the next video we are going to add a little bit of optimization to the Minimax algorithm using alpha beta pruning. Wow, it bit me right there. Wow. And if you don't know about alpha beta pruning, I recommend you go and watch the Wikipedia pages for it. It's really basically allowing the Minimax to not consider options or columns when the score is definitely lower or higher depending on who's playing next. It's just a little bit of optimization for our code, and we're going to do that in the next video. Oof, almost had it here. Let's see. Oh, where did it win? Here. Yeah, and one thing I do want to add in the next video, or the one after, is I don't like the player 2 to play right immediately after I drop a piece, because as you can see, it's hard to see where the player dropped the piece, or the AI dropped the piece. And I think at some point I'm going to add some sort of visual indicator of what was the winning move. Maybe some flashing of the pieces that made the winning move, maybe. But yeah, there are definitely some improvements, and we are going to start with optimization in the next video.